So in our examples here, we're going to condense into a single logarithm, simplify if possible. I added in a little bit more specific directions, which are not on your paper right now, but what we're really doing is we want to write each of the following as a single logarithm. So there's the condense idea with exponents. This means that we're only going to write one logarithm in our condensed version. So what we need to notice when we look at this first problem here is we need to notice the plus sign, because the plus sign tells us, as you look back up to your properties, that we're going to be using the product property. Since there is a plus in this problem, we can rewrite this as the log base a of 7 times 3, and then we want to simplify if possible, and we can simplify. 7 times 3 is 21. I wrote parentheses in there. I don't think that we really need to have the parentheses in there, but it's fine. Look at the signs or look at the operations in the problem. That can give us an indication of what we need to do. On problem number 2, the operation that we're working with here is minus. When we look back above at our properties, minus indicates that we're going to turn this into a quotient, the quotient property. So this is going to become log, and then it's going to be 3 divided by 8. And we can't simplify 3 divided by 8 any further. If we look at problem number 3, 4 times the natural log of x. Well, when we simplify this, what we want to do is we want to write this without the exponents. Or no, we want to write it with exponents, sorry. So we're going to take this value of 4, and this is our third property, and we're going to take that coefficient and turn it into an exponent. So this becomes the natural log of x to the 4. And having seen problem number 3, here are example number 3, let's look at problem number 4, which also has that same idea. When we have a coefficient on our logarithm, we're going to make it an exponent. So we'll start there, and this is going to become the log of x cubed plus the log of 6. But now that we've got the plus in this problem, we also have to use the product property of logarithms. Plus indicates to us that we can rewrite this problem as x cubed from 6 and I am fine with that answer, but oftentimes it's more acceptable if you have the number as the coefficient. So I write the or, but this is going to be log 6x cubed. Number 5 looks a little bit different from our previous problems, but it's not really. What we're going to do, first of all, is we're going to follow the order of operations, which says that we need to do parentheses first. So yes, we have a coefficient on this problem, but we need to simplify what's in those brackets first. And what we see in terms of operations is we see a minus sign, and minus indicates that we're going to use the quotient property of logarithms. So we can simplify what's inside our brackets here into the log of x divided by 3. Now we still have this 2 out in front of it, but a coefficient, a number in front of a logarithm, is simply going to become an exponent using the power property of logarithms. So when we finish this particular problem, this becomes log of x over 3 squared. And just a quick reminder, x over 3 squared, if we simplified that more, would be x squared over 9. What's inside the parentheses gets raised to what's outside the parentheses. And here, log parentheses x divided by 3 squared, quantity squared, is our answer. As we look at number 6, what I'm hoping you notice is we have 8 log x minus 6 log x. These are like terms. So we can simplify this a little bit more just by combining this before we apply the properties. 8 minus 6 is 2 log x. And now that we know that, one more time we need to apply this power property of logarithms, which says that if we have a coefficient, a number in front of the logarithm, then it is going to become an exponent. So we're going to take this value of 2 and we're going to make it an exponent. We're going to get log of x squared.